Hello, I welcome you all back to this wonderful lesson. And in this particular lesson, this is a question that I want us to look at under physics, radioactivity. If you are new, make sure that you consider subscribing so that each time I upload a new content, you get to be notified. So the first question is saying, define radioactivity. How can we define radioactivity? So for you to define radioactivity, for those of you that have been following me, I gave you the definition for radioactivity where I said that radioactivity is the spontaneous disintegration of any unstable nuclei emitting alpha and beta particles and gamma rays. This is what I told you, and that is the definition you need to put there, just calling 1 mark. So you just get a mark. So then we move now to the next question. The next question is saying radon nuclide. This is the radon nuclide. So it is like this. Let me write that one here. So it is like this. This is what we are given. Radon. So 86 proton number, or rather the atomic number, just one and the same. This is the mass number or neutron number. So this is what you are given, 2022, and this is 86. Decays to form polonium Pa by emission of an alpha particle. Write the decay equation. They just want you to write the decay equation. So how is the decay equation going to be? You are going to do this. This is what you are going to do. Then it is emitting an alpha particle. You put the symbol for alpha like that. This is what you are going to do. Then you are going to say what is being formed is polonium, which is Pa. Then we know that whenever something is emitting an alpha particle, what gets to happen is that the proton number, this one, the proton number reduces by 2. So 86 minus 2, you are going to get 84. Then the mass number reduces by 4. So when this one reduces by 4, we are going to get 218. This is what we are going to get. So then you say plus, we know by nature an alpha particle is the helium nucleus. You do this where you put a 2 there and a 4. So this is the answer. This is the decay equation that you are supposed to put there. Hope you've seen how I've come up with this, and this is what you are supposed to do. We move now to the next question. The next question is saying that figure C3.1 shows the results obtained to determine the half-life of the radioactive element. There is a word here that has been introduced called half-life. You need to know what half-life is. What is half-life? Half-life is the time taken for any radioactive substance to decay by half of its present material. So if you are taught to define half-life, this is what you are supposed to do. Then a radioactive material is a material that undergo radioactivity. So any material that undergo radioactivity is called a radioactive substance or a radioactive material. So going back to the question now, this is the figure that is showing the results obtained to determine the half-life of the radioactive element. The first question is saying, plot a graph of active, which is counts per minute, against time, which is in minutes, for the element. You are given 4 marks for that. So what you are supposed to do now is where you get your graph. So I believe you've got a graph. You are going to get your graph like this. This is your graph that you have. So I believe we are all having graphs. You put a line here. That's just this one. So you put a line here like this. This is what you are going to do. So just leave here, last to last. This is what you are going to do. And you are supposed to use a pencil. I'm just using a pen so that you are able to see everything that I'm going to do. So I'm using a pen so that you are able to see everything like this. This is what you are going to do. You do this, even there, you just leave one box. Like this, even there, you put a line. This is what you are supposed to do. I believe you are able to see this. So you just determine that. So this is what you are going to do. So you do this. This is what you are supposed to do. So like this. So you know that, okay, this is the what? This one here, this is the x-axis. You are going to put x there. Then here like this one on top there, here you say this is the what? This is the y-axis. This is the y-axis. This is what you are going to do. From here now, what you are supposed to do is that you know that you are plotting a graph of what? A graph of active against time. So this graph, you put a title. So you put a title, you say it is a graph of, so you put a title, graph of active. So graph of active, so graph of activity, graph of activity against time. This is the name of the graph. Against what? Against time. This is what you are supposed to do. These are some of the things that you need to get and understand. I believe you are able to see this. So after that, you look at the values which are given. So you are going to look at the values which are given. These are the values. So they are saying that a graph of what? Activity against time. So time is in the x-axis. What is activity on the y-axis? So meaning that this is the x, this is the y-axis. That one on top is the y-axis. This one down is the x-axis. So you check. Have you seen how these are moving? This is the x-axis, 0, 5. Have you seen 0, 0.00, 0.5, 1, 1.5, 2, 2.5, 3, 3.5. Have you seen how they are moving? So now you say, which scale are you going to use? So you say, okay, the scale, this is what you need to do. You go to a scale, you say scale. The scale that you are going to use, you say this is the x-axis. On the x-axis, you are going to say, since they are moving by 0.5, 0.5, you are going to say 2 centimeters is going to represent what? 0.5. 2 centimeters is going to represent 0.5. This is what you are going to do. You check the y-axis. How are numbers moving here? Have you seen how are numbers moving? 5, 7.5, 9, 14, 18.5, 24, 34, 42. So you check, okay, for this scale to be fit, what am I going to do? I'm reaching up to what? 42. So you say, what if I say, so you are reaching the highest number is 42. So you say, okay, on the y-axis, this is what I'm going to do. On the y-axis, I'm going to use a scale of what? I'm going to say, okay, 2 centimeters is going to represent 5 units. This is what I'm going to do, 5 units. Even there, that is 0.5 units. This is what you are going to do. So it means here you'll be moving by 0.5, 0, 1, 1.5, 2, 2.5, like that. On the y-axis, you'll be moving in 5s. 5, 10, 15, 20, like, just like that. So we can go ahead and label our scale. So this is what we are going to do. So this one here is a 0 that is there. So you say this is the x-axis, 0.5. Here you put 1, 1.5, 2, 2.5, 3, 3.5, then a 4. So I can end on a 4. It is just okay. So I can end on a 4. The highest number is 3.5, like that. So meaning my scale is just okay. I check. The y-axis is this one. So I'm moving in 5, 5, 5, 5. So I do this. I will be moving in 5s. So this is 5. So you label clearly 5, 10, 15, just like that. We can continue. 20, 25, 30, 35, 40, 45. So this is the scale. We've done that. We know that on the y-axis, what are we having on the y-axis? Activity. So I'm going to say activity. This is what I'm going to do. Activity, which is what? Counts per minute. This is what I'm going to do. Time on the x-axis is just in minutes. So I'm going to say time. So I'm going to say time is just in what? Minutes. So this is what I'm going to do. This is what you are supposed to do. So from here now, you start plotting now. So you say, okay, what's the first coordinate? What's the first coordinate? So the first coordinate, this, you know that you are doing, this is x, this is y, 0,42. So before we measure this 42, we need to know how the scale is moving on this axis, which is the what? Y-axis. For me to reach, have you seen from here up to there? There are how many small boxes? There are 10 boxes, meaning that 2 boxes, it is 1. So that if I count here, 1, 2, 3, 4, 5. So I'm counting 2 small boxes as 1, so that I reach at what? 5. So meaning that on this axis, 2 small boxes, it is 1. So I say the first coordinate. What is the first coordinate? To check. The first coordinate is given here. What is the first coordinate? 0,42. 0,42, I check, okay, on the x-axis, 0 is here. So I move, I find 42. So 40 is here. So I say 1, 2, 41. 1, 2, 42. So the point is just there. Have you seen? This is what I'm going to do. Because 2 boxes, it is 1. So this is 40, 1, 2, 41, 1, 2, 42. So I'm done with that. I move now to the next one. So the next one, what's the next one? I check. The next one is 5,34. 5,34. Where is this is a 0.5. So 0.5. So I go to 0.5,34. So 0.5 is here. I move. 34. 30 is here. I start counting. 1, 2, 31, 32, 33, 34. So 34 is where? 34 is there. That is where my 34 is. I think you're able to follow through. You're able to see everything that I'm doing. I move to the next one. 1,24. 1,24. Where is 1? 1 is here. So I move to 24. 1. Along 1 here, I move 24. So if you count, 24 will be there. If you count, you know that 2. Just 1, 2, I reach a 25 there. I go to 1.5, 18.5. So 1.5 is here. 18.5, I move 18.5. So I know that if I say this is 15, have you seen? That is 15, 16, 17, 18. So 18.5, it is just here. This is where 18.5 is. So it is just there in the middle, so that this one is 19, 19.5, 20. So that is where I'm going to put that. Then I move to the next one. I move to 2,14. 2,14. This is what I'm going to do. 2,14. 2, where is 2? 2 is just here. This is where my 2 is. I go to 14. So 14, this is 10. 14, this is 15. 1, 2, I just move 2 steps backward. This is 14. This is where my 14 is. Have you seen? This is what you are supposed to do. These are some of the things that you need to get and understand. From there now, you go to 2.59. 2.59. So 2.5 is here. Where 9? This is 10. I just 2 steps backwards. Downwards like this. Have you seen? That is 9. If you want, you can count 1, 2, 6, 1, 2, 7, 1, 2, 8, 1, 2, 9. You can count if you want. From there now, the other thing that you are going to do is you go to 3, 7.5. 3 is here. This is 5, 6, 7.5, just 1 box there. This is where I've got 7. You say 1, 2, this is 6. Have you seen? This is where 6 is. And this is where 7 is. Now, the next one there, that is 7.5, such that that one will be what? 8. Then that one will be 9. This is what we are doing. So we just said that one. And I've told you that you are supposed to use a pencil, not a pen. So the last one, it is what? 5, 3.5, 3.5, 5. 3.5, 5 is this one. It is here. So now what we are supposed to do, we are supposed to connect this. So I'm supposed to connect this using a straight line. So I connect this. This is a curve. Have you seen a straight line is not being formed? So I'm going to connect this. I'm going to do what? I'm going to connect this. This is what I'm supposed to do. So I need to do what? I need to connect these ones. So the way I'm supposed to do them, I say, okay, this is what I'm going to do. So this is what I'm having. How do I connect now? This is what I'm going to do. From there, I connect these. Have you seen? So I just connect these points. And how am I going to connect them? Like this. This is what you're going to do. So you just do this with your hand like this. Just connect these ones like this. So this one is supposed to pass through there. Just connect them like that. Like this. Have you seen? This is what you are supposed to do. So this one is supposed to pass through there, even that one there, like this. This is what you are supposed to do. It should just be a curve. It should just be what? A curve like this. So the reason why I've done this is because I'm not in the right position. But at least I'm able to show you what you are supposed to do. The things that you are supposed to consider. So this is what you are supposed to do. Have you seen? This is what you are supposed to do. So these are some of the things that you need to get. These are some of the things you need to understand even in an exam. So have you seen I've missed out this point? Because if it passes through there, have you seen I'm going to have something like that. So if this point it passes through there like that, it's more like my curve will bend like that. Have you seen? But it's better you just pass it like that. But if you want to know that if it comes there like that, you go there like that. Have you seen? It's better a curve is just like this. Have you seen? You are able to see this like that. The way it is like this. So this is what you are supposed to do. You just need to make a curve. Have you seen? A curve, just a curve. So this is what you're supposed to do. Then we move now to the next question. The next question is this one. I don't know if you are able to see it. This is the question that is here. We are saying determine from the graph the half-life of the material. So the half-life of the element. They want you to determine the half-life. So how are you going to determine the half-life? Since the highest number on the y is 42. So what is half of 42 is 21. So what you are going to do, half of, you get that one, 42, half of that. So you are going to get half of what? 42. What is half of 42 is 21. So you go where 21 is. 21 is here. This is what you are going to do. 21 is just there. This is where 21 is. So what you are going to do, you are going to put a line like that. You put a line like that. This is a line you are going to put. Then here you check the value that is there where it is landing. So you get a value there. You do this. This is what you are going to do. So this is what you are going to do. These are steps that you are supposed to do. So you are going to do this like this. You get a value that is there. Have you seen? This is the value that is there. So which means here, this is what? This is 1. So 2, it is 0.1. Have you seen? 0.1. So I say, okay, 0.1, 0.2, 0.3, 0.4, 0.5, like that. So this is at 1.2. So the half-life is what? Half-life of that element. So the half-life is that, the half-life is what? 1.2 minutes. So this is the half-life. We've answered the question, which is 2. It is what? 1.2 minutes. This is what you need to do for you to determine the half-life. So the same way I've done that, that is what you are supposed to do. Have you seen? So half-life is what? 1.2 minutes. This is what you need to do, get, and understand. So we now move on to the next question. We now move on to the next question, which happens to be our last question, which is saying, state one possible source of background radiations. So the possible sources of background radiation, you know that these are naturally occurring radioactive minerals in the soil, ground, and water. So the list of them that you can put there, you can say these can be internal radiations. You can put another one, which is you can say radon gas. It is also a source of these radiations. You can also put medical and industrial sources. They can be also the sources of this background radiation. So you can put any answer that you are comfortable. Thank you so much for watching. I believe you've learned one or two things. Don't forget to subscribe. This is my official channel.